Hi, this is Mrs. Vrobel. This is Chapter 15, Part 2, Energy and Chemical Changes. So in this video, we're going to look at how do you determine what is enthalpy and what is the heat of a reaction. And then you're going to precisely determine how a thermochemical reaction is written and whether energy is lost or gained. So this is a little bit of a review from the last section. Here we're looking at thermochemistry, and thermochemistry is a specific form of chemistry that looks at heat changes that occur with a chemical reaction. And the chemical reaction listed down here is iron reacting with oxygen and forming iron oxide. And notice that there's some energy that's related to that reaction. Okay, so system. System is a specific part of the universe, so it could be a flask, it could be a beaker. We only care what's going on in that flask or that beaker. The surrounding is anything outside of that glass or that beaker. And then the universe is a combination of the beaker or the flask and anything outside of that beaker or flask. Okay, enthalpy. Enthalpy is the heat that's generated or absorbed by a system, and it occurs at constant pressure. Now today we're going to look at enthalpy, or the heat of a reaction. And notice with that, we're looking at the heat that is given off by products minus the heat that's given off by the reactants. Not every substance will give off heat. It may take in heat. Now, if you're looking at an exothermic reaction, notice that the heat will be, or the energy will be negative, whereas if you're looking at endothermic, you're going to be looking at positive energy. Okay, so here's a heat pack reaction. So if you had to guess, is this a exo or endo reaction? Good. So notice that there's a negative sign here. Okay, so if this is negative, it's exothermic. And I'll show you an example of this in class. We can have the reverse. So here is an example of a endothermic reaction, and notice that there's a positive sign. Therefore, it's absorbing energy. Okay, so thermochemical equations, we have the reactants and products, and they're written along with the enthalpy or the heat. I'll show you an example of this. Now, the interesting thing is, with thermochemical equations, we can have fractions. And the reason why we have fractions is we're representing moles, not molecules. And also, you want to pay attention to the fact that energy is represented by kcals per mole or kilojoules per mole. Okay, so you could take a thermochemical equation and you could double it so you can get the correct number of moles. So notice that the carbon monoxide and the 1/2 oxygen, which yields carbon dioxide, if it's doubled, you have to apply it to the energy. So if you double the whole equation, you have to double the energy. Also, if you want to change the direction that the chemical equation is written in, you just have to change the sign of the delta H. So if it's positive and you flip it, it becomes negative. Okay, and then for pure substances, you usually have it occur at 1 atmosphere, and the temperature is usually 298. If you have an element, its heat will be 0. So if you have hydrogen gas or oxygen, those elements will be 0 enthalpy. So please remember that heat of reaction is measured where we take the heat of the products minus the heat of the reactants. Okay, so I have a reaction here. They want to know what is the thermochemical reaction and how much is released if you have 1.6 grams of a substance. So the way I'm going to write the thermochemical equation is I'm going to rewrite the whole thing. Notice I'm including the coefficients and the states that they're in. So if I have a gas, I put a G. And then I also include the energy when I'm writing this. So because it has a negative 11 kcals per mole, it's part of the it's part of the product side. So I'm going to include the 11 kcals per mole on this side of the equation. If it was a plus sign, it would be part of the reactant side. But this energy is given off. Now they want to know if I have 1.6 grams of hydrogen. So all I have to do is convert that to moles. And then I'm going to multiply it by the kcals per mole to get just kcals. So I'm going to divide 1.6 by 2.2 grams, and that gives me 0.799, 794 moles. And when I multiply that by 11, I get 8.73 kcals. Okay, so in summary, heat lost or gained by a system during a reaction is called change in enthalpy. If you have delta H, which is positive, it'll be for endothermic reactions. If it's negative, it'll be for exothermic reactions. Also, enthalpy changes can be measured for a reaction, which is the heat of the products minus the heat of the reactants.